Good morning. I'm Padmapriya, Assistant Professor in Department of CSE in RMD Engineering College. Today we are going to see the topic binary tree under the subject data structures. In a normal tree, every node can have any number of children. Binary tree is a special type of tree data structure in which each node can have a maximum of 2 children, that is left child and right child. In a binary tree, every node can have either 0 children or 1 child or 2 children, but not more than 2 children. A binary tree consists of a node, that is a root node, and left and right subtrees. The nodes at the lowest level of the tree are going to be called as leaves. Now, in this diagram, A is going to be called as root node. B, D, F, I, J is going to be the left subtree. C, G, H, K is going to be the right subtree. I and J and K. So these three nodes does not have any child and it is at the last level in the tree. So they are going to be called as leaf node. And B is going to be the left child of A and C is going to be the right child of A. And D and F is going to be the left child and right child of the node B. Whereas G and H is going to be the left child and right child of node C. For D and F, the parent is going to be B. For G and H, the parent is going to be C. For B and C, the parent is going to be A. And it is going to be the root node also. It is the node from which all the other nodes emerges. So this is going to be called as root node. Now let us see the types of binary tree. The first binary tree is going to be full or proper or strict binary tree. So the full binary tree is also called as strict binary tree, as the tree can be considered as a full binary tree if each node must contain either 0 or 2 children. The full binary tree can also be defined as a tree in which each node must contain 2 children except the leaf nodes. Now this is the example of full binary tree where A has 2 children B and C and B has 2 children D and E. If any one node is going to contain one child, then it does not become a full binary tree. Now let us see the complete binary tree. The complete binary tree is a tree in which all the nodes are completely filled except the last level. In the last level, all the nodes must be as left as possible. In the complete binary tree, the nodes should be added from the left. Now let us see the example of complete binary tree. So for 10, 20 and 30, left child and right child is being filled. Likewise, for 20, the left child and right child is being filled. For 30, the left child and right child is being filled. And same for 40, the left child is being filled. So in the last level, all the nodes is not being filled. And the nodes which is being filled is also as left as possible. So this is the complete binary tree. Now let us see the perfect binary tree. A tree is a perfect binary tree if all the internal nodes have 2 children and all the leaf nodes are at the same level. So then it becomes the perfect binary tree. So if you see here, 1 contains the children 2 and 3, that is, it has 2 children. Similarly, 2 also, the node 2 also have 2 children 4 and 5. Similarly, the node 3 also have 2 children, that is 6 and 7. And all the leaf nodes, that is 4, 5, 6, 7 are at the level, same level. Now let us see an example which is not a perfect binary tree. Here, the leaf nodes are 6 and 7 and 2. So these nodes are not at the same level. Even though all the nodes are having 2 children, the leaf nodes are not at the same level. So this is not a perfect binary tree. Next comes the degenerate binary tree. Degenerate binary tree is a tree in which all the internal nodes have only 1 children. So if all the child is going to be right aligned, it is going to be called as right skewed tree. So 10, 20, 30, 40, 50. So these nodes are going to be forming a right skewed tree as 20, 30, 40, 50 are the right child of each and every node. The next comes a degenerate binary tree where all the nodes are going to be left aligned. And each and every node has only one child and all the child is being left aligned. So this is going to be called as left skewed tree. Thank you.